Okay, result 33.
Okay. Hello. Can you hear me and see my screen? Oh, okay. And what about the screen? Can you see in the presentation? Okay. Okay. Good morning and good evening for everyone. Let's start. And here it's Jim again. And here our today's topic is about some key parameter instruction. So I will introduce some important parameters about our driver, which is commonly used. And here you can see we have four parts today. First part is some parameters in basis control. First one is this one, control mode. Yes, I think you know because here we have already introduced position control, speed control, and torque control last week. And also here have three mixed control mode we can select. You can see, for example, if we select control mode 4, then here we need to use a external DI terminal to change the control mode between position control and speed control. Use a DI, and here for the DI function code, we need to set it as 17. For example, if we use DI1 to switch the control mode, and when DI1 is 0, our server will run in position control, and when this DI status change to 1, the server will work in speed control mode. Okay. And the second part is about bucking resistor. You know, our servo will have a built-in bucking resistor, but not all model have built-in bucking resistor. Here you can see for small type driver, for example, these two, and also we have a small one, 007, 003. For these two size driver, we have no built-in bucking resistor. But for other driver, we all have a built-in bucking resistor. And for the built-in resistor value for A type, we are using a 50 ohm. Wait. And the 50 power for A type driver. And for B type driver, we use 50 ohms and 80 watts bucking resistor. Resistor. So when you are using built-in bucking resistor for parameter P0 and 9, you need to set this as 0. And its default value is also 0. But sometimes the built-in bucking resistor maybe have no enough power. So in this condition, we need to connect an external bucking resistor. And for external bucking resistor, we need to connect also we need to connect 50 ohms, but the power we may need a bigger one. So how to calculate the power of our bucking resistor? We can use SC tool and use this function to calculate it. Example. Yes, you can see with different condition, the recommended bucking resistor watt is different. Okay, let's continue here. And here, after we connect an external bucking resistor, we need to set P0 and 9 as 1. And also we need to enter the external bucking resistor value and power in P0 and 10, P0 and 11, these two parameters. Here, the default value is 50, and also we recommend to connect a 50 ohms bucking resistor. If the bucking resistor is too, for example, is too small, the motor maybe report an overcurrent error. So 50 is recommended value. And here, these three parameters is used to set the PPR of our motor. And I have already introduced this in our first training. Second training in position control. For P0 and 17, yes, sometimes, for example, the driver is have a very short time to speed up and slow down. I means do a forward and reverse movement in a short time, and frequently the internal bucking resistor may be damage it. because because it have no enough power to work. And here how to use our electronic gear, these two parameter. For example, the received pulse number, and you can check here. If we use P0 and 16 directly, then what we set in this parameter is the PPR we used. But if you use P0 and 17, P0 and 18, these two parameters to set the PPR, the PPR will be calculated by this left part. You can see in the receive pulse number, and multiply this EG value and divide the servo resolution, and we'll get our PPR. Here, servo resolution is depends on the encoder. We have 17 and 26 bit, these two type, and here this is for 70 motor. And here for P0 and 30, this parameter is used to ignore the encoder battery error, because for multi-term motor we need to connect a battery for our encoder cable. How much of the pulse is received and saved to calculate? Yeah. For example, here. Okay. Here, for example, if we want to set the PPR of our motor as 1000, if we use this parameter, we can directly set here as 1000, and it will work. But if we want to use this parameter, these two parameter, and also set PPR as our motor as 1000, how to set? As I said, we need to set. This is our PPR we want. For example, when we receive 1000 pulse, and this calculated by our EG ratio. Here, ER means EG ratio, and divide. Sorry. This one should be 1. 1 means 1 turn. So you can see the receive pulse number, and calculate with EG ratio, and divides our resolution of our motor encoder, and this value should be 1. So it means when the servo receive 1000 pulse, the motor will rotate 1 turn. And here we can see this ER should be should be this one. Okay, so we set this to here and set 1000. Set 1000 to here. Okay, so with this relative setting, we will get 1000 poles and make motor rotate 110. Okay. And okay, let's continue. Okay, for here, P0 and 30. For this parameter, as I said, for multi-term motor, we need a battery to make the encoder cable works. If there are no battery or the voltage of the battery is too low, the driver will give an error. Error 40, I remember, yes. So, but sometimes, for example, you have no battery and also you don't want to use multi-term function. You want to use the multi-term motor like a single-term motor. So in this condition, you can set this parameter as 0. As 0, let me check. Oh, sorry. Is oh, I sorry. Here we should set this parameter as 1. Set this parameter as 1 to clear the battery error, and we can use our motor normally, like a single-term motor. And for 0 and P0 and 31, this parameter because they have an alarm A93. This alarm means the communication between motor and driver is not stable. Maybe there are some interference inside, or the encoder cable is not good. So in this condition, we will get alarm 93, and we can use this parameter. This parameter set this as S0 to so the driver will not report A93. So usually, sometimes we can set this as 0 during debugging. But in last, when we are run in real projects, we should check the cable, and make sure the cable is work normally. Because if we directly set this at 0, and in projects run when the system running, maybe there are some communication question between driver and the motor. So the position may be not correct if we set this as 0. So as I said, during debugging we can set it at 0. But when working, we usually use default value. Okay, and the next is control source selection. This is for position control. Position control, I say there are two sources, pulse and the internal position. We have already introduced how to use pulse to control the motor, and there will be another training to introduce how to use internal position instruction to control the motor. And below here, for bounce speed and torque mode, we can use internal speed, torque, and or we can use external analog inputs to control the speed or control the torque. So this is this parameter, and also, and to say again, is VD2F doesn't support analog input. And this parameter is our last class for self-turning. Self-turning, we need to set this parameter. Okay, and here need to notice for load inertial ratio, we can check it in monitoring value U0 and 20. And for this P3 and 3 for this parameter, if we are using manually setting, we need to set this parameter as 1. Otherwise, after repower, our setting control parameter will change back to default value. Okay, and now I will introduce some parameter, IO relative parameter. First one is this analog inputs, analog input bias and analog zero drafts. For these two parameters, I also introduced them in speed control. Yes. So I think we can skip this part. And also here, this parameter is used to set the analog range and the speed range. Yes, and also the relationship a bit of analog range and torque value. DI function selection and DI logical selection. Function code, you can check the function code table to select it. And also in SC tool, you can also see it. DI input here. This is our function code. And for logical, we can set how to say positive logical or negative logical. Here also is DI function codes table. And for DI input source, there are two sources, hardware and virtual inputs. For hardware, for example, we need to connect PLC output to our driver CN2 terminal. But for virtual input, we will use this 13 group parameter to set the DI status. And also we can use Modbus communication to change the virtual DI input status. And here for part 3. Part 3 first for P10 and 2. This parameter is used to reset our servo, parameter. So if you don't want to lost your setting parameter, you can export the parameter before you reset the servo. And here you can export parameter by this button. Here. And for 10 and 4, this parameter is used to clear error. Before you clear error, you should check the error first, because if you didn't solve the error and you clean the error will report again. And here for some parameters, you can see, for example, for this parameter, it will take effects after power on again. So if you change this parameter, you can see the driver will report A86, I remember. No, sorry. Will report an 83 or 86. So if you don't want to repower, you can use this parameter to clear the alarm, clearly alarm, so you can use driver continue and without repower. Because sometimes some user will use model bus to modify some parameter which require repower. So in this condition, we can also use this parameter, use model bus to modify this parameter to clearly alarm, and we don't need to repower the servo. For this parameter 10 and 4, this parameter is used to protect our motor. Sometimes motor will work in overload condition. If the overload time is not too long, maybe only 1 second or only 2 seconds, so the motor can work normally, I mean. But if the overtime is too long, maybe the motor is working in overload conditions more than 10 seconds or 20 seconds and or more, our driver will report an error to stop the motor to protect it. So this parameter is to set the time, set the how long the overload error will report. For example, for default setting is 100%. For example, maybe over 2 seconds, our driver will report this error or this report, this alarm. If we set this as 200, it means after 4 seconds, after the motor work in overloads more than 4 seconds, the error will appear. And then, for example, if we set it as 800, it means maybe 16 seconds. After 6 seconds, the driver will begin to display the error. So we can adjust this parameter to how to say because for some working for some application or for some condition, maybe our motor will need to work in overloads maybe more than 4 seconds or more than 5 seconds. So if we use default 100, the error will always report this error and just stop the machine. So in this condition, we can make this time longer to make our driver working. But how to set this parameter? I mean, because if we set this parameter too long, it will make our motor work in overload status too long. Sometimes it may damage our motor. So how to check or how to set this parameter? You can check the temperature of our motor. If the temperature of the motor will not heating, as you can see here, if the motor temperature will not be too high or continue to heating after in overload condition, then we can set this parameter as a bigger one. But if the parameter of the motor is always rising and rising when it's working in overloads, so in this condition we don't recommend to increase this value because it may damage your motor. For now, there are no parameter to show the motor temperature now. So we need to use another tool, temperature measure tool to check the temperature. Yes. And below these two parameters is used to set our motor codes manually, because in a very few condition, the motor code may be wrong, or the motor code may be lost. So in this condition, if we connect the motor to driver, the driver will report an error, error 26. Yes, so if we want to solve this, we can set a correct motor codes for our driver, for our motor by these two parameters. How to set? First, we need to set P's 10 and 7, set this parameter as 1. And then the second, we need to enter our motor codes in parameter 10 and 5. But what's our motor codes? You can calculate it like this. In our motor nameplate, there will be an motor code. For example, for 750 watts motor without buck device. For this motor, the motor code is A and 0. This is motor code. So you can see we need to set this 40998. We need to set this parameter in P10 and 5. So you can use this tool to calculate how much the value we need to set in P10 and 5 according to the motor codes in our motor nameplate. And the last is P12 and 4. This parameter is used to, if we set it as 1, then the parameter we set to our driver by Modbus communication. The setting parameter will keep remind after repower, because we will write the value to EEPROM of our driver. Yes, but default is 0, and if we set it as 1, we need to ensure the Modbus the writing time will not be so frequently, because there will be a certain writing time of our EEPROM, maybe 100,000 or 200,000. And if we write more than this value, then our driver will not count. Our driver will not be able to set the parameter any longer, because the EEPROM is damaged. So when you set this parameter as 1, you need to ensure, for example, in PLC program, we use M0 and RS instruction to write the value. This M0, we after one writing, we need to reset M0. So in this condition, we will not always writing. So to protect our driver EEPROM. Okay, now last part is some monitoring parameter. First is some parameter about motor working status. U0 and 2 is our motor running speed, RPM, and U0 and 20 is our real-time load initial ratio. 0 and 31 is our bus voltage. Because sometimes the driver will report over voltage of our over voltage, or how to say, the voltage is too low. The bus voltage is too low. So in this condition, we can check the U0 and 31 to check our bus voltage in normal range or not. For example, for 220, for 220 watts, 220 voltage driver, the bus voltage should be bigger than this value. Otherwise, the motor will report an error. The U0 and 40, this parameter is the output power of our driver. 0 and 39 is the load torque percentage. So you can check this value. Check U0 and 39 to check the load of our how bigger the load is. Usually this parameter motor can work normally when this parameter is smaller than 110%. In a long time, I mean, will work normally when the load is below than 110%. If the load is bigger, for example, 120%, 150%, and even 200%, for different loads, the motor can the working time of the motor will be shorter. For example, maybe in 120% load, the motor can work 4 seconds and then reports overload error. And in this, maybe can only work 2 seconds and report error. And for this, maybe can only work 1 second and then will report an overload error. And here have some monitoring parameter about our encoder information. First, for U0, for these two parameter is will be cleared to 0 after we power on. So this two parameter will not keep its value after the power. And for these three parameter, for U0 and 50 and U0 and 56, for these two parameter is used in multi-turn motor. So for single-turn motor, these two parameter will not works. And here have some version information about driver. For U2 and 4 is our firmware version, and for U2 and 5 is our FPGA version. And sometimes maybe we need to upgrade the firmware of our driver to solve some question or solve some bugs. Then we need to check the correct firmware version first, and then give information to our technical, our technical, and our technical will tell you which version to upgrade and how to upgrade. And also here have some parameter how to create parameter, create firmware. I will show it later. Here first we need I want to say these two parameter, U0 and 8 and U0 and 9. These two. These two is input commands post number and the input commands post frequency. So if in position mode, our motor can't run, but the driver is already in run status, so we can check these two parameter because if this two parameter is zero means maybe there are some winding error because our driver didn't receive the pulse in fact. So we need to check the value or check the PLC side. Maybe PLC side didn't send pulse. Okay. And now I will introduce how to use how to upgrade the firmware of our driver. You can see here have a FAQ link, and here shows how to upgrade the server some firmware. Before we need to remote to upgrade the firmware server firmware, but now you can upgrade it yourself. So you can see here first you need to set the you need to download the server firmware upgrades package in this link here here for VD2 VD3 series and the VD2 series firmware. You need to download it, and after download, you need to connect the server to our PC. For VD3 type, I already download, but current fail. What's the failed you mean? Connect fail. Which part you mean between PC to server, right? Or you mean here this didn't keep continue. I will send video to you later. Keep okay. You can send the video to me later. And here is the steps about how to upgrade. So you can check this link. I will send the link again. And here last. Okay, here is our today's content, and finish it. So here you can see here have no too much contents. And for today, we don't have homework for today's training. Yes, so you will have more time to finish it in the homework from day 1 to day 5. Okay. And okay, and let's all thanks for your watching. Do you have any question? Yes. Today we have no homework. Today is only some parameter instruction. But oh, said you need homework. Well, you are you are okay. Thank you. Okay, and we will same time tomorrow. We will continue our training. Okay, and see you tomorrow.